Okay, this is the #1 final review for the first semester of geometry. You're going to do a couple of things here, so you're going to see the problem on this page, and then I'm going to put a problem for you to do on another page, perhaps even 2 more pages. You are going to find the midpoint and length of the segment. So first we're going to plot it 5, 4, because I want you to see a visual of what it looks like. So 5, 4, and then you're going to plot -1, 2. Now you don't make a line here, you just connect it with a segment, because we're going to find the distance of that line, and we're also going to find the midpoint of that line. So first we'll start with the midpoint. We'll do that in blue. The midpoint formula just says take the x values. It's going to be an ordered pair because it's a point on a line. Your x values are 5 and -1. Add them together, and when you divide by 2, you're going to get into the middle or find the midpoint. Then take your y values, so 4 and 2, add them together and divide by 2. So the formula is, the midpoint formula is simply, in parentheses, because it's an ordered pair, x of 1 plus x of 2 divided by 2, comma, y sub 2 plus y sub 1 divided by 2. And that's going to give you your midpoint. 5 plus -1 is 4 divided by 2, which equals 2. So your first ordered pair, your x coordinate is 2. 4 plus 2 is 6 over 2. So your x coordinate is going to be 3. So 2, 3. So when we go 2, 3, that in fact does look like the midpoint of the line. Now, we're next going to look at the distance formula. Let's use a different color for distance. So the distance formula is going to be d equals the square root of x of 2 minus x of 1, because you're finding the distance between the x coordinates, squared, plus the distance between the y coordinates, y sub 2 minus y sub 1 squared. And that's going to be this is related to, the distance formula is related to the Pythagorean theorem, a squared plus b squared equals c squared. And you're going to see that relationship here in just a minute. So we'll find the distance in just a minute, but I want to first show you, let's use a different color. If I go 1, 2, 3, 4, 5, 6, this is going to be a square that is going to be 6 by 6, which is 36. And then off of this side, you have 2, 1, 2, and that's going to be a square that is 4. So the side is 2, and that's a square that is 4. So we have 36 and 4, which means that the square that comes off of here is going to be 40. And that means the side then will be the square root of 40. So the length of this segment is going to be the square root of 40. Now let's look at how it looks when we actually do the math. So d equals the square root of x sub 2. You can choose whatever you want for x sub 2, but you have to be consistent. I'm going to choose 5 for x sub 2. So 5 minus -1, and we're going to square that, plus. Now since I chose 5 for x sub 2, then I have to choose 4 for y sub 2. So 4 minus 2, that's going to be squared. So d equals the square root of, now I want you to use the subtraction rule in these. So it's going to be 5 plus 1 squared plus 4 minus 2 is 2 squared. So d equals 5 plus 1 is 6. So square root of 6 squared. 2 squared is 4, so plus 4. d equals square root of 36 plus 4. d equals square root of 40, which is exactly what we thought we would get, was the square root of 40. Now, that's the exact answer. And the square root of 40 is between the square root of 36 and the square root of 49. Square root of 36 is 6, square root of 49 is 7. You end up a little bit closer to the square root of 36 because it's not quite in the middle. And when you plug it into your calculator, d is going to be approximately 6.3. These are This is the exact answer and the approximate answer. Okay, now you're going to try one, then you're going to check your work, then you'll try another one and check your work just to make sure that you understand it. The model, the graphing, you could be asked questions like that on the final, and it's also to help you with your understanding, and that understanding of the distance and formula's connection to the Pythagorean theorem, a squared plus b squared equals c squared. So on your piece of paper, write down the problem, use a piece of graph paper to sketch this, show everything as it's being shown. You will do the problem first and then you will check it. Okay, here is problem number 1. M is -3, 4, N is 1, -2. I want you to graph it. I want you to show your triangles just like we did in the previous example. I want you to get your answer before you even calculate the distance. Midpoint, you simply use the formula, but then I want you to look at the segment and see that the midpoint is actually falling at that point, just like we did in the previous one. When you finish, turn it back on and check everything, fix any errors. Okay, you can see I've plotted in blue -3, 4, and I've also plotted 1, -2. And then I go ahead and find the midpoint. I did that in red, so I took the x-coordinates, -3 and 1, added them together, divided by 2, because that's going to give me the middle. -3 plus 1 is -2, divided by 2 is -1. That is your x-coordinate. Your y-coordinates are 4 and -2. You put them together with addition. You're going to divide by 2 to find the middle. 4 and -2 is 2. 2 divided by 2 is 1. So the ordered pair for the midpoint is -1, 1. And you can see that that looks like it is pretty much the midpoint of that segment. Now the distance of this line, I did the sketch first. I made a right triangle. Again, this is a right triangle here. And I am 6 high and 4 across. And 6 squared is 36. And 4 squared is 16. If you take 36 and 16, this is just the Pythagorean theorem. A squared plus b squared equals c squared. The two legs squared and added together equal the square of the third longer side of the triangle, which is 52. If you want to know the side, the hypotenuse of that, then you take the square root of the square size. So the square root of 52, not a perfect square. That's what we came up with in the distance formula. Here's how we got it. We went x, the distance formula. The distance formula is x sub 2 minus x sub 1 squared plus, in parentheses, y sub 2 minus y sub 1 squared. So I took -3 minus 1, squared it, and then I took the corresponding y value, 4 minus -2, squared it. I want you to use the subtraction rule here, so it's -3 plus the opposite of -1 squared, and then 4 plus the opposite of -2, which is 2 squared. -3 and -1 is -4 squared. 4 plus 2 is 6 squared. So d equals the square root of 16 plus 36. When added together, d equals the square root of 52, which matches what you had right here. And then we know that the square root of 52 is between the square root of 49 and the square root of 64. The square root of 49 is 7. The square root of 64 is 8. So the answer is going to be a little bit closer to 7 because square root of 49 is closer to the square root of 52. And when we plug it into the calculator, d is approximately 7.2. Okay, so you're all set up now for this number 2 problem, which is f is -4, -1, g is -2, 4. Please graph the points, draw your segment, calculate your midpoint, plot it on the point, draw in a right triangle, find the distance of the segment using the Pythagorean theorem, then check that using the distance formula, which is given for you. When you're finished, turn it on and check your answer. Okay, you had -4, -1, you plotted it here, f, and -2, 4, you plotted it over there. The midpoint is -3, 3/2, or -3, 1.5. It appears to be correct when you look at the graph. After doing your squares, you off of the side of you make a right triangle. Off of the side of 2, you got 4. Off of the side of 5, you got 25. 25 and 4 is 29. So the square that came off of this segment was 20, its square was 29. The side length is the square root of 29, which we actually calculated with the distance formula. It is between the square root of 25, which is 5, and the square root of 36, which is 6. When we calculated it on the calculator and rounded to the tenths, it was D is approximately 5.4. Okay, we're going to move on to bisectors next. Okay, continuing on, we're going to find x, the variable x, if angle ABC is being bisected by ray BD. So here's angle ABC, ray BD is bisecting, and all that means is it's splitting the angle into two equal parts. Well, if angle ABD, so if angle ABD equals 56 degrees, then angle DBC equals 56 degrees. And that means that they're going to equal a total of, so angle ABC is going to equal 112 degrees when you put them together. So that's what ABC is, 112 degrees. So we know that angle DBC, 3x plus 5, equals angle ABD, 56 degrees. They are congruent because a bisector cuts something into two congruent parts. Using algebra, we subtract 5 from both sides. Using the subtraction property of equality, we end up with 3x equaling 51. Divide both sides by 3. Our goal again is to get x isolated. Using the division property of equality, 3 goes into 5 one time with a remainder of 2. Put that little 2 there. 3 goes into 21 7 times. X equals 17. Now you're going to go ahead and write down the next two problems, number 3 and 4. You're going to do them. Once you're finished with them, turn the recording back on and check your answers, fixing anything that's incorrect. Okay, so go ahead and write down the problems. There's 3 and 4. Again, angle ABC is being bisected by ray BD, which means that ABD is going to be congruent to DBC. Okay, in angle 3, you have 5x set equal to 25 because the two angles are congruent. Using the property of division, divide both sides by 5, so x equals 5. To find what the whole angle ABC is, you would just add 25 and 25 and get 50 degrees. For number 4, you would have angle CBD, which is 3x minus 3, being congruent to ABD, which is 72 degrees. You would add 3 using the addition property of equality, which would leave you with 3x equaling 75. Using the division property of equality, you would divide by 3, and you would end up with x equaling 25. Again, if you were to want to know both of the angles, 72 and 72 would give you 144 degrees put together, so that would be the measure of angle ABC. You can also check to see if you're right by plugging the 25 in. So 3 times 25 is 75, minus 3 is 72, so they are in fact congruent. Go back up to number 3. You plug in 5 into the x position. 5 times x is 25. 25 is congruent to 25. Make sure you write all of this stuff down because you will be turning the paper in to me.